Hello, my name is Graham Reid. I'm a student at Heriot-Watt University and I have been working on a project for the Quality Assurance Agency for Higher Education, or QAA. The project is geared at improving student experience learning about programming. The idea being we have a test program that is able to look at students' code, identify whether it fulfills the criteria, whether it's correct or not, and if it's not, then it's able to identify where the students are not succeeding and offer them targeted advice based on that. The idea being that it gets them moving forward faster than if they had to wait for a lab helper that might not necessarily be available at that time. As part of the process of improving this program, we ran a lab with some first year students who are doing software development 2 and 3. We gave them the sample lab along with the test program and asked them to use it whilst trying to complete the lab, and then give us their feedback on how the tool worked. And based on the feedback from the students, we implemented a number of changes which I'll discuss in just a moment. So this is an example of the test program before the changes that we implemented based on student feedback. As you can see, this is a mock-up of a kind of typical lab that students would do, completed with various answers. This lab in question, the students have been asked to create recursive methods for summing numbers, for multiplying numbers, and for generating the Fibonacci sequence up to a certain number of digits. One of the key things about the test program is that you don't need to give the program the individual names of the methods. It will sort of search out the methods and test each one of them in turn, and check if it fulfills certain criteria, and if it finds one that fulfills the criteria of the lab, such as a recursive method that returns the sum of numbers given, then it will award you a success for that. Okay, so I'll quickly run this to demonstrate it in use. We run the test method. It looks at the student's answer class here. It goes through each of the methods seen here, and it checks each of them for the criteria for success. So for the sum of numbers, it checks whether it's recursive, calls itself. As you can see, we've given it a recursive method and a non-recursive method, so it looks at sum2, but in the end it discards that and it returns sum as the correct answer. Again, with multiplication, it goes through all the methods, but it identifies multiply as the correct one. And for the Fibonacci sequence, again, it goes through all the methods, but finds Fibonacci fulfills the criteria, so it awards a sort of success for that. Now, some of the feedback that the students gave us was that the answers are quite difficult to see. As you can see, we're making heavy use of the console here, so we moved on to using pop-up windows, and I'll demonstrate that in a minute. So this is the updated version of the program. We're looking at the part 1 of the same mock lab that we had previously. So I'll run it again just now, and hopefully things will be a bit clearer now. So there we go. We've got two methods, one non-recursive and one recursive, but the program is able to identify that there is a recursive sum of numbers method in here that returns the right answer, so it gives you a success result. Now, part of the feedback that we received from students for the previous version was they were looking for more targeted advice, so I would like to demonstrate that just now as well. For example, if we take out the recursive method, we've still got a method that will return the sum of numbers, but it's no longer recursive. So this isn't a fully correct answer, but the student may not realise that. So if they run the test now, you can see that advice pops up. It tells them that although the answers are correct, the method doesn't call itself. It then starts to give them targeted advice based on this, telling them to have a look at base cases, make sure they aren't relying on for or while loops, and then just generally try and put them onto the right path. Hopefully the idea being that they'll be able to not just know that they haven't succeeded, but why, and will be able to fix it themselves. If I then take out all the methods entirely and run it, you'll see in this case the computer assumes that the program assumes that the student hasn't managed to get their head around making methods at all. So in this case the targeted advice is based on how to form a method correctly. So it gives them the general breakdown of it here. It gives them a very simple example, and then it kind of gives them some more advice in the body here. The idea being, instead of just referring students to their entire wedge of notes for the entire year, it can give them the relevant section, and hopefully they'll be able to see where they've gone wrong, and we'll be able to highlight common pitfalls, and again just get them moving forward again. I had mentioned earlier that the program doesn't need to be given the names of methods. It can look at the class and search out the methods and test each one of them in turn. The idea behind this is we didn't want to stifle students' creativity by giving them a mostly or partially complete class where they were just filling in a couple of blanks. We wanted them to be able to essentially learn how to write classes and methods from scratch and really get the fundamentals under their belt. So a student can call the method whatever they like. So for example, I can change this, call it test sum 1, and this one here I'll change to test sum, I'll call that 2, and because it's recursive calls itself, I'll have to change this as well. But then if we save that and run the program, you'll see that despite the names being changed, the program's still able to come into the class, look through them and identify that one of them is correct. It's recursive and returns a sum of numbers. And then also if I was to remove the correct answer, it's still able to find the new one and give advice on that. So basically the students are able to call their creations whatever they like and build them from the ground up. I hope this demonstration has been of some interest to you. Thank you very much for taking the time to watch it. Goodbye.